So we are going to ultimately use the distributive property a whole bunch of different ways, but we're also going to be multiplying and factoring. So let's talk about some vocabulary first. The word factor has two meanings, and context is everything. Context is everything. Anyone know what N stands for when you're talking about words? Noun. So when factor is a noun, that's a person, place, or thing, or idea. And in this case, factor means it is a number that can divide another number evenly. A number that can divide another number evenly. So oftentimes you'll see it written like this. What are the factors of 12? And you could just think about how you can break up 12, and some factors of 12 are 12 and 1, 12 times 1. We could say 6 times 2. We could say 4 times 3. These are all factors. 12, 1, 6, 2, 4, and 3 are all factors of 12. It is true that 7, you can divide 12 divided by 7. It gives you a number. It's just not a whole number. So that's when we say that's the evenly part. All right, the second way we're going to use the word factor is when we use it as a verb. V stands for verb. You don't need to memorize the parts of speech here. I just want to clarify that we do have different ways to do it. So factor, when it says to factor this or factor that, it means to write as a multiplication problem. So take whatever the expression or the number is and turn it into a multiplication problem. So, for example, factor 2x plus 4. And the answer would be this: 2 times x plus 2. Why? What did we do? We undid the distributive property. Or if I said factor 12, and you would say, oh, 12 factored is 4 times 3. What I did was take the original number or the original expression and rewrite it as a multiplication problem. So I like to remember something like this and say factor always means you're going to write it as a multiplication problem. So let's look at the greatest common factor. What is the greatest common factor? It's the largest number that divides evenly these two numbers. So let's think about this. What's the largest factor of 12 and 36? What is the largest number that divides both of them? And the answer here would be 12. Because 12 divided by 12 is 1, 36 divided by 12 is 3. What about here? 15x and 20x. Well, if we just consider the number, what's the largest number that divides both of these? The answer is a 5. And what about the x? What's the largest letter that divides both of those? An x. So there is your largest, there's your GCF, 5x. Now, in the case where you don't instantly see the answer, and you need to do some breaking of things, you can use what's called a factor tree to start breaking things up. And notice one thing that is common, I don't even have to think about it. What's common is we have a subtraction, or the negative. So I'm going to consider that as something that's common, a -1. Next, I have a 2 here and a 2 here. I have another 2 and another 2, and a third 2 and a third 2. 2 times 2 times 2 is 8. Notice what's left over here is just this 2, and what's left here is a 3, which are not common. And then if I look at the letters, I have a pair of x's, so I can bring that down, and notice the remainder over here is just an x, so I don't need to consider that. So my final answer down here, what's the GCF of these two terms? -8 squared, or -8x, -8x. All right, so let's take a gander here. We're going to factor each expression completely. Remember what factor means. This is the noun. It's a command telling me to do something, which means I need to write the expression as a multiplication problem. Because right now, it's a subtraction problem. It's this term minus this 7m. So how do I write it as a multiplication. Well, what's the GCF? What is common in both of these? Well, notice I have an M and an M, so M I'm going to put on the outside. In other words, I'm undistributing. I'm dividing both terms by the GCF. Now, what's a common factor of 14 and 7? Well, a 7 works. So when you take this 14m squared and divide by 7m, we get 2m, m. And when I take a 7m and divide by 7m, I get 1. How do I know I'm right? Because when I distribute this here, I get 14m squared, and distribute here, I get negative 7m. So my final result is this. That's factored form. Another way of saying this is to factor out the GCF. You might see it written like that. Please factor out the GCF, and your final answer would be 7m times m minus 1. Well, if I were to factor out, I need to factor out something that's common in all these terms. Do all of these have a letter? This term here, and this one over here? Holy. And the answer is no, they don't. So this one does not have an x. But what number can divide all of these? What's the largest possible number that can divide them all? Well, I can pull out a 12. Now someone says a 4. That's true, but you can factor out even more. So when I divide everything by 12, I get the first one is 4x squared, the second one is 2x, and the last one is positive 3. Now, there is no common letter, and a 4, a negative 2, and a 3 cannot be factored any further, or no GCF. So this here would be factoring completely as far as I know. We are actually going to, this week, we're going to teach you how to factor this right here, if possible. And the reason for that is so that we can spend some time solving quadratics. And we'll look at examples of that in a little bit. All right, what about C? What can I factor out? Only a 9. So x squared plus 2 is what's left inside. So 9 comes out, x squared plus 2 is inside. On number 2 here, I can factor out an 8, but also the letter m. So I end up getting 2m plus 1. And number 3, what can I factor out of all of that, please? That's it. I can factor out a 2, and that is all. So I get ax squared plus 11a plus 30. And we might be able to factor this next part right inside here, but we will talk about that later. Just a little bit of background before we spend our time factoring is I want to make sure we understand what it means to multiply out. So take a gander here. We are going to look at using the distributive property in a couple different ways. The first big way you may have heard of is called FOIL. When we have a problem that looks like this, and our job is to simplify the expression, here's too commonly what happens. So eyes on deck just to see the mistake, or the error. Some people say this, oh, well, let me just take the 3x and multiply those, so I get 3x squared, and then let me take the negative 4 and multiply it there to get negative 20. Yay, I'm done. But the problem with that is what we're saying is all of these terms are multiplying all of these terms. So really what we should do is take the 3x and send it to both terms. And then we have to take the negative 4 and send it to both terms as well. Made a mistake on that. So we're going to show you the process on the way to do that. And I'll show you 3 different ways to look at it. I don't care which method you like, which method you prefer. I found that all of these work for different people. So the first method I want to call is the box method. It's also known as Punnett squares. Biologists here, Punnett squares. This is exactly what a Punnett square is. So let's just show you how to do this method. It's called sometimes area model, sometimes called Punnett squares. But what we do is just make a little grid. And I'm going to take this guy here, 3x and minus 4. I'm just going to write it down the side. And I'm going to take this guy here, and I'm going to write it along the top. It doesn't matter if you write them, switch those around. And I wrote the x plus 5 along here. In the end, it doesn't actually matter which method or which way you write it. Now remember your Punnett squares, what you did was just take this here and multiply this here, and you write the answer in there. So let's do that. So I'm going to write that answer here to get 3x squared. Next, you take this x, negative 4, and you write the answer inside the box, negative 4x. This 5 is going to multiply the 3x, so I write the answer there to be 15x. And lastly, this 5 multiplies the negative 4, and I'm going to write it inside there to be negative 20.
Isn't this one a
In the end, we just start picking this apart. This one is all by itself, so 3x squared is what I get. These two right here are like terms. In this context, they are. So negative 4x plus 15x is positive 11x. And the negative 20 is by itself. So when asked to multiply out or simplify this, these two binomials are called, this is my final result. Now what we're going to do in the next couple days is actually teach you how to go backwards. But I do want you to make sure that we can go forwards first to see what we're doing, to see that it's rather complicated. So to going backwards, we'll teach you the math skills to do that. Let me jump over here to FOIL just to show you what we mean by that. And some people have already stated what FOIL means. It is an acronym. FOIL means firsts, as in those two. Firsts mean the first in that group and the first in that group. So that's 3x squared. And then the O means outers. So outers can be like those two. So that's 15x. And then the I means inners, which are these two right here, negative 4x. And then the L means lasts, and that's an A. And that would be like the negative 4 and the positive 5. And notice this is just like the box method. And what we just do now is combine things. These two can combine to 11x. And then my final result will be the same. 3x squared plus 11x minus 20. And notice we got that answer before when we simplified. So, but instead of thinking of it in terms of box, I thought of it in terms of letters. FOIL, FOIL, firsts, outers, inners, lasts. So we'll just look at it a different way. I generally will stick with this, double distribution, where you just send this. The 3x goes there, and the 3x goes there. So that's 3x squared, and that's plus 15x. And now the negative 4x goes there, or excuse me, the negative 4 goes to both of those. And then we just combine like terms and simplify. 11x minus 20. Again, every single one of these methods gives you the exact same result, and it's all about you choosing your path. So don't forget what square means. Square just means take exactly what you see and multiply by itself. X minus 9 times x minus 9. So when we do our double distribution, I get x times x and x times negative 9x. Next, I have negative 9x again. And lastly, positive 81. Some things that are quite often happen in terms of mistakes, so just watch out. These will not cancel out because they're both negative. And pay attention, it's not 9 plus 9 to get 18 here. You're multiplying those two last ones. And now, when I finally write the answer, I get this. Minus 18x plus 81. Now there is a shortcut, a pattern, that at some point in time we will see, but for now, we'll just point out that when you have a square term, just write it as two separate parentheses or binomials, and then do your FOIL double distribution, etc.